So multi-step. Multi being more than one. So before, we saw addition, we subtracted. We saw multiplication, we divided, so forth. Now, we're going to add 2 steps. There's 2 things going to be going on. So, isolate the term containing the variable you are solving for. That's the goal. Get that x by itself. Okay? Like I said, it helps to circle or underline that variable. To solve an equation, you essentially want to use your properties to get the variable alone. Try to get it by itself. You may need to combine like terms first. So 5x plus 2x equals 17. You're going to want to get 7x before you do anything. Okay, equations involving fractions may be easier to deal with if you multiply all terms in the equation by a common denominator. In other words, if you multiply it by a common denominator, you get rid of the fractions. There'll be no fractions left. Okay, they're gone. Then also watch out for the need to use the distributive property. In order to get rid of expressions with parentheses. And remember, when you distribute, make sure you distribute to everything inside the parentheses. So, let's see what we got here. Now, do I have equations up on the board? Are those equations?
No.
No. What's missing? Equals 9. So right now we're just practicing combined like terms. That's all. So what I do when I have a big mess like this, I like to organize it. You don't have to do this. It does make life easier, I promise you. And so like I'll just go through and like underline all my x's and maybe put a squiggly line or a V or whatever under my numbers, a squiggly line under y's. Just a way to visually organize and separate what's there. And that way you can also make sure you get everything. Okay? So I have 5x minus 2x minus x. So if I have 5 x's and I take away 2 x's, that leaves me 3 x's. Now if I take away another x, that leaves me with 2x. And then 3 plus 4 is 7. Alright? Now, there's really no reason here to underline anything because they're all A's. But one thing I do want to be careful about is that double negative right here, which really ends up being plus. You can also look for shortcuts like this. 2a and negative 2a cancel each other out, right? There's no reason to add 2a and then subtract 2a. Just notice that they cancel each other out. So now all we have is 6 minus 3. 3a. Okay? Now, we're trying to find the common denominator. Because if we could do that and multiply by that number, it'll get rid of all the fractions. So 3, 5, and 15. The number they all go into would be 15. And now think about it. If we multiply 15 by the first one, 1/3 of 15 is 5. No denominator. Multiply by the second one, 5 goes into 15 3 times. Times 3 is 9. No denominator. And the third one, the 15 would cancel. 2. No denominator. So multiplying by that number gets rid of all the fractions, which, people don't like. 4, 5, and 2. Okay, well, 2 goes into 4, but 4 doesn't go into 5. 2 doesn't go into 5. 10. 2 and 5 go in, but 4 doesn't. 20. Boom, there we go. 20 is a number that all 3 go into. 4, 5, and 2. 4 goes in 5 times, 5 goes in 4 times, and 2 goes in 10 times. If you ever need me to stop, just let me know and I'll go back. Okay, so here we have the two-step equations. Remember, we kind of already hinted this before. You're working backwards. So instead of PEMDAS, I can write. We undo with SADMAP. SADMEP will undo PEMDAS. So we're going to go backwards. So again, find your x. It's right there. You can underline it or circle it. Now ask yourself, what's happening to it? It's being multiplied right by 4 and increased plus by 3. So we got to do two things, right? We got to divide by 4 and subtract 3. But we got to go backwards. Now here's how you think about it. If I took a birthday present, okay, and I put it in a box, and then I wrapped it with wrapping paper, can you open the box before you take off the wrapping paper? No. You got to undo what I did, right? Now, did I wrap it before I put it in the box? Yeah. No. I put it in the box, then I put wrapping paper over it. So, putting it in the box is my multiplication division, right? First step. Wrapping it is my second step, adding and subtracting. But what do I have to get rid of first? The wrapping paper. So I have to undo it in a backwards way. So I need to get rid of the 3 first. You work backwards. So I'm going to subtract 3. Cancel. Remember, show all your steps. 4x equals 16. Now that I have it down to 4x, x is being multiplied, I'm going to divide by 4. Now, you don't have to do this, but like someone in the hallway asked me, how can I get an A in this class? Here's how you get an A in this class. Do you turn in a test and wonder what you got on the test? You got a good grade? Yeah. The beauty of algebra is most times you can turn your test knowing whether you got the problem right or wrong. Let's say I screwed up and put 5 right here. I don't know how. But let's say I got x equals 5. You can take this and plug it back in here and check your answer. So let's say I got 5. 5 times 4 is 20, plus 3 is 23. Is that equal to 19? No. That means I got the wrong answer. So instead of moving on to the next question on the test, not knowing if I got it right, I can plug that in and check my answer. Let's say you made another common mistake. Let's say for some reason you got negative 4. Okay. Negative 4 times 4, negative 16. Plus 3, negative 13. Is that right? No. So it tells me go back and check my work. Often in algebra, you can check your answers before moving on. If you want to know how to get a good grade in this class, how to pass this class easy, check your answers before you go on to the next problem. Okay? So here we go again. We locate our variable, first step. Boom, there it is. Now 2 things are happening to it. It's being multiplied by 1/2, and it's being decreased, subtracted by 5. Okay? So I put the gift in the box, and then I wrapped it. You have to take the wrapping paper off first, right? What's the wrapping paper? The negative 5. How do I undo subtract 5? I add 5 to both sides. The 5's cancel, giving me 1/2 x equals 15. Now remember, when we have a fraction, we undo it by multiplying by the reciprocal, standing on its head. So the reciprocal of 1/2 is 2 over 1, or simply just 2. Cancel, x equals 30. But again, the beauty of math. Take this 30 and plop it in right there. 1/2 of 30 is 15. 15 minus 5 is 10. Check. I know I got it right before I even move on to the next page. That's how you pass this class. That's how you get an A. Check your work. I have it happen all the time. I have kids turn in tests 20 minutes early, half an hour early, and have silly mistakes. Use that time to check your work. Okay, same thing, except on this one, remember, you should always see if you can simplify first. Join like terms. So before I start diving in and getting rid of that 17, I'm going to join like terms. Now, I'm not saying if you got rid of the 17 first, you'd be wrong. You could get rid of the 17 and then join like terms and then divide. It's okay. There's more than one way to do it. It's just usually a little bit easier to clean it up first. So 2 take away 9 is negative 7. Be careful with that. It's negative 7x plus 17 equals negative 4. Now, once again, back to the analogy. Here's my x. That's my present. I put it in a box, and then I wrapped it. So this is the box, and this is the wrapping paper. And if it helps you write that down, just do you remember when you're looking over your notes how we're doing this? Do it. So, to get it back to the present, after I give it to you, you have to unwrap it first. By subtracting the 17. Take the wrapping paper off. Now, you might be one of those people that like to just take it out carefully so you don't rip it, and you might be like the dog and just rip into it. Whatever, I don't care. Your goal is to take this wrapping paper off. Subtract 17. What that leaves you is negative 7x equals, okay, negative 4 minus 17 is negative 21. Now, I found my variable. What do I divide by? Negative 7. Because remember, it's being multiplied by a negative 7, so we divide by a negative 7. And all those giggling that he got that wrong, at least he answered it and tried it.
I had it right on paper.
That's fine. But there are people snickering because you got it wrong, but at least you put out an answer and tried. And I'd rather you try it. Now, you don't have to fire back with the eyes. So, the negative 7x cancels. Because think about it. Let's say you did divide by 7. What's negative 7 divided by positive 7? Negative 1. And we don't want a negative 1x. We want a positive 1x. So we want it to cancel, which happens over here with 3. Now, let's say we did that. Let's say we divide by 7. Our answer would be negative 3, right? Make sense? Yes? So let's say we took this bad boy back up here and plugged in, well, let's go back here actually, negative 3. Negative 3 times negative 7 is positive 21. Plus 17 is 38, not negative 4. So that would tell me I made a mistake. And I have to go back. And anytime there's negatives, always go back and check that first. But if I plug in positive 3, I get negative 21 plus 17, which is negative 4. It checks out. All right, over here on this one. A lot going on here. Okay? N is being increased by 1 and divided by 2. All right? This is the box, usually, but actually I want to do this is normally we think about the box as being multiply and divide, but think about it. In this case, to even get to here, I have to get rid of this first. Because the whole top is being divided by a negative 2. So in this case, we need to multiply this side by negative 2 and this side by negative 2. Now, that leads me to n plus 1 equals negative 30. Now remember, positive times negative is negative. Now, show your work. Subtract 1, n equals negative 31. Which, again, we plug back in right there. Negative 31 plus 1 is negative 30. Divided by 2 is negative, divided by negative 2 is positive 15. 15 equals 15, it checks out. Okay, same concept here. There's more practice. Okay, we want to get to this A. The problem is the top is being divided by 5. We got to get rid of that denominator first. So we do that. Multiply by 5, multiply by 5. So that's negative 15. So we got, sorry about that. There. Negative 15. Positive times negative. Equals, the 5's cancel. Be careful here. Negative 4 plus A. Here's the most, listen carefully, please. People see this and go, oh, it's adding, so subtract 4. But what's being added to it? It's being added by a negative 4. Another way to write this is a minus 4. In that case, if it was written a minus 4, all of you would obviously go add 4. But the problem is, people see this plus sign and go, oh, subtract 4. Okay? You got to add the opposite. So since this was a minus 4, we're actually going to plus 4 on both sides. See how those cancel? If we minus 4, we get minus 8. And we don't want that. We want to cancel it. So that gives me A equals negative 15 plus 4, negative 11. Again, we plug that in there. Negative 4 plus negative 11 is negative 15. Divided by 5 is negative 3. My answer checks out. Now, is that extra work to check your answers? Yes. Does it take all of about 10 seconds? Yes. Is it worth that 10 seconds to figure out if you got it right or wrong when you're waiting to not take this class again? Yes. And this goes for next year when you're in geometry or when you're taking Algebra 2. Unless you love taking math in the summer, check your work. The key to passing math is checking your answer whenever you can. It helps tremendously, I promise you. Okay, now look at the difference between these two problems. Here, the letter's being divided by 4, and then subtract 3. This is the wrapping paper in the box. The first example, 5, was different because the letter and a number was being divided. We had to get rid of that denominator first. In this case, we can go back to what we did before and get rid of the 3 first. You got to pay attention to where that division is. Okay? Since the division is just with the letter, we're good to go. We add 3 on both sides. That gives me W divided by 4 equals 10 plus 3 is 13. Now, how do I undo division? I multiply by 4. And again, we're not multiplying by 13, we're not dividing by 13. Ask yourself, where is my variable? Boom! It's W. What's happening to it? It's being divided by 4. 4's cancel, giving me 13 times 2 is 26, times 2 is 52. And if I take 10 seconds and plug that back in, 52 divided by 4 is 13, minus 3 is 10. Check. All right. Now, if you look at the first, you don't have to go back, but if you think about the first page of notes, I said distribute whenever you have a number like this in parentheses. You don't always have to do that. Now, listen carefully. If this was 37, I would have to distribute the 2. Okay? If this was 9, I would have to distribute the negative 5. And I can do that. Okay? So let's do it that way. Let's distribute. So we're going to send the 2 in and send the 2 in. Remember, if you know yourself, if you're one of those people that traditionally forgets to distribute all the way, draw the lines. Remind yourself to put it in both numbers. So that gives me 6x plus 18 equals 36. Now we're right back to a two-step problem. First we get rid of the 18. 6x equals 18. Divide by 6. X is 3. Plug it back in and check. 3 times 3 is 9. Plus 9 is 18 times 2, 36. Good to go. But there's a faster way to do it. Go ahead and write that again, please. There's a step I can do to make this faster that I could not do if that was 37. What can I do? Everybody see it? If that was 37 or 35, I couldn't do it. Good divide. What does this 2 outside the parentheses mean? Multiply. Is 2 being multiplied by the parentheses? Yes. How are you going to do multiplication? Divide. Now, would it make sense if this was a 37 over here, divide by 2 and get a decimal? Would that help me? It'd be kind of a pain, right? But since that's an even number over there, you don't have to do this. It's just a shortcut. But if you see these things, right, since this is an even number, can we just divide by 2? Then, subtract 9. Divide by 3. Same answer. But we saved ourselves a step and we had smaller numbers to deal with. Doesn't matter. If you do it the first way, it's not a big deal. But think about what you're doing. You're multiplying everything by 2, you're going to end up dividing by it again. So over here, first step, multiply everything by -5. Negative 20n, careful, plus 15 equals 5. So first thing we're going to do is minus 15 on both sides. Negative 20n equals negative 10. Divide by negative 20. N equals positive 1/2. And again, let's plug it in. 1/2 of 4 is 2. 2 minus 3 is negative 1. Negative 1 times negative 5 is positive 5. That's our answer. Yes, it's a fraction. It's okay. We can get fractions and decimals for answers. But let's rewrite it real quick. Negative 5, 4n minus 3 equals 5. Please rewrite that. Again, if you did the first way, that's fine. Not a big deal. But, is 5 divisible by negative 5? Is 5 going to 5? Yeah. So watch. If I divide by negative 5, I get 4n minus 3 equals negative 1. Add 3. 4n equals 2. Divide by 4, and guess what I get? Same answer. I'm just dealing with smaller numbers. So, like I said, you don't have to do that. And if this number was not a multiple of 5, if it was 6, 7, 8, 9, 4, 3, 2, 1, wouldn't work. You'd have an nasty fraction to deal with. But if it's a 5, a 10, a negative 20, you can divide by negative 5 first, if you want. It's just a shortcut. All right. More practice, same thing. So, first off, I want to change this to plus 4. Subtracting a negative is the same as adding positive. Now I'm back to a two-step equation. Okay? I want to get rid of the 4. Boom. 12 minus 4 is 8. Now again, it does not matter if the letter's on the right side. It doesn't matter whether it's left or right. If you're uncomfortable with this, you can rewrite this as 2d equals 8. And some people are, and that's okay. Some people like to have the letter. When I was in high school, my teachers were like just very strict. They like you never have the letter on the right side, which is ridiculous. But they just it was silly. But you can rewrite it if you want. D equals 4. Plug it back in. 2 times 4 is 8. 8 plus 4 is 12. Check. Okay, number 10. Same problem, basically, except we have a fraction. That's okay. It's not going to throw us off. First step is still to get rid of that 10. So we're going to add 10 to both sides. Cancel. 14 plus 10 is 24. Now, we want to get rid of the 1/7. We do that by multiplying by the reciprocal. The reciprocal is 1/7 flipped. So 7 over 1. But it's silly to write 7 over 1 because that's really just 7. The 7 cancels that, and we're left with t equals 7 times 4 is 28, 14, 168. Which you can plug back in here. 168 divided by 7 is 24. 24 minus 10 is 14. We are good to go. Last two, right? No. That's it. Two more lines. Okay. So, there's more practice. Remember, we have two numbers to get rid of, the -3 and the 5. But the -3 is division, the 5 is addition, so we want to get rid of the 5 first. That gives me m divided by -3 equals -24 minus 5 is -29. Now we undo division by multiplying. Careful here. What do we multiply by? Not that hard. Find your variable. M. What's happening? It's being divided by -3. We undo division by multiplication. If it's divided by -3, we multiply by -3, which cancels. Over here, -3, which is going to lead me to a positive answer. 9 times 3 is 27. 3 times 2 is 6. That's 87. Which you can plug back in, divide by -3, add 5, and you will get -24. I'm going to do the shortcut on this one because 28 is even. So we can start off by saving ourselves some time and getting rid of that -2. So -14 equals 3k minus 4. Remember, if that was an odd number, you couldn't do that. Okay, so at this point, we want to get rid of the -4 by addition. When we do that, we get careful, -10 equals 3k. That's not k, that's next. 3k. Divide by 3, and there's our answer. K equals -10/3. And yes, we can have a fraction for an answer. So look, let's plug it back in. It's not as scary as it looks. -10/3 times 3, the 3's cancel, it's -10. -10 minus 4 is -14. -14 times -2 is positive 28. It works out. So just because it's a fraction doesn't mean it's wrong. Okay, practice multiplying fractions. There's two ways to go about this. This is really 8 over 1. Okay? You don't have to write 8 over 1, but it is 8 over 1. So you have two choices. You can do 8 times 3 over 4. 24 over 4, which is just simply 6. Okay? You can do that. And you can do this mentally. Or, if you think about it, doesn't 4 go into 8 2 times? 2 times 3 is 6. Faster, but it doesn't matter. So again, this is 30 over 1. You have two choices. You can do 4 times 30, and get a big number, need a calculator. Then divide by 15, probably need a calculator. Or Doesn't 15 go into 30? Who? Sorry, dude. Forgot to unlock it. Oh, thank you. How many times 15 go into 30? What's 2 times 4? No calculator needed. Now, once again, if you did 4 times 30, that's 120. And 120 divided by 15 is 8. Doesn't matter which way you do it. You can do 6 times 14, which is 84, and then divide by 7. Or 7 goes into 14 2 times. 2 times 6 is 12. It doesn't matter what you do first. Multiply and divide. They're equal. So divide first, you usually get smaller numbers. Now, if this was 7, you couldn't do it. If this was 32, couldn't do it. But you can. 5 goes into 20 4 times. Negative 8. You can do negative 2 times 20, get negative 40. Divide by 5, get negative 8. That's fine. You can multiply first, then divide. Or you can cancel first, then multiply. It's up to you. I prefer to cancel every time I can. Okay, this is what we talk about, finding common denominator. Who wants to deal with fractions? Raise your hand. Let's have fun with fractions. Yay! Nope? Okay. So, what's the first number that 3, 6, and 12 all go into? Not what goes into them. When I'm looking for a factor, I'm looking for a multiple. 12. Okay? So the LCD is 12. Least common denominator is 12. Watch this. If I multiply by 12 here, and I multiply by 12 here, then I multiply by 12 here, watch what happens. This is what we just did. We can do 7 times 12 divided by 3, right? Or, can you cancel 3 into 12? You betcha, because it is a common denominator. What's 4 times 7? 28. 6 goes into 12 how many times? 2. So that's going to be 2 times 5 is minus 10, oh sorry, plus 10x. I don't know why I put minus that. And then here the 12 just cancel, equals 7. Okay? So what's my first step going to be here? Minus 28. Okay? So minus 28 on both sides. And we're going to get a fractional answer here. That's okay. 10x equals negative 21 divided by 10. And yes, it's okay. Our answer is negative 21 over 10. Now, when I said go back and plug it in, this would be kind of nasty to plug in here. But it's not nasty to plug in here. If you plug it in here, the 10s cancel. So you just get 28 minus 21, which is 7, good to go. So it's still easy to check your answer. You just don't want to do it here. You want to do it here. Okay, this one. LCD is 8. 2 goes in 8, 4 goes in 8, 8 goes in 8. So I'm going to multiply each number by 8. Or each fraction by 8. Okay? So, 2 goes into 8 4 times. So that's negative 4. 4 goes into 8 2 times. Times 3 is 6. And here the 8's cancel, equals 5. So, add 4 to both sides. 6a equals 9. Divide by 6, and a equals 9/6. Which, if you plug back in here, the 6's cancel. 9 minus 4 is 5. And if you reduce this, that would be great too. So 3 goes into that 3 times. 3 goes into that 2 times. So 9/6 with 3 halves. That's a big one to say. Okay, now we're just translating a little bit. Practice. Okay? So watch how easy this is. Okay? We're going to translate like we talked about before, word for word. 3, that was tough. More than, plus, twice a number. We usually pick X, right? Twice a number is 35. That's it. That's how easy it is. Word for word. Okay, then it said solve it. So we're going to subtract 3 from both sides, which will give us 2x equals 32. Divide by 2. X is 16. So let's check it. 3 more than twice the number. Twice 16 is 32. 3 more than 32 is 35. Boom. Okay, 5 times the number. 5 times the number. See how complicated that was? 5 times the number, 5x. Decreased. Decreased. By 10 is equal sign 90. Another toughie. So, first thing we're going to do is add 10 to both sides. So that gives me 5x equals 100. Divide by 5. X equals 20. Let's check it out. 5 times our number. 5 times 20 is 100. Decreased by 10 is 90. 100 minus 10 is 90. Last, the product. That means multiplication, right? So the product of a number and -7 is 294. Just divide by -7. X equals 7 goes into, so it's going to be a negative number for one thing. 7 goes into that 4 times. 4 is 28, 14, -42.